Laurent, c'est où la clé? Bon, moi. Shared with because I cannot see. Pour partager l'écran. Juste une question. Attendez ici. Ok. C'est bon, c'est fait.
Okay, shall we start?
Missing Ella.
Yeah, there is.
Hello, can you hear us well?
There's a little bit of echo, George.
The echo.
Now it's okay. Can you hear us?
No, it's okay. No, it's okay.
Stefano, can you speak a bit?
Can you hear me also?
Yes, very well.
All right.
Yes, correct.
Is that
we can start.
All the members of the jury are present?
Yes.
Okay. Okay, so shall we start? So good morning to all of you. So I'm the president of the jury. So it's a great honor for me to share this discussion of this PhD thesis. So I would like first to compliment all the members of the jury and obviously to extend my compliments to the candidate, wishing him all the best in the discussion of this thesis. And so we are going to discuss the thesis, which title is Control and Scheduling of Hybrid Hydropower Plants with Batteries for Enhanced Flexibility in Future Power Systems. So, Stefano, I suppose you know the rules, but you have at maximum 45 minutes for the presentation, and afterwards the discussion will follow. So the floor is yours, Stefano.
Okay, thank you very much for the introduction, and thank to all of you that are being here today or connected virtually. My name is Stefano CASSANO, and today I'm going to defend my PhD thesis titled Control and Scheduling of Hybrid Hydropower Plants with Batteries for Enhanced Flexibility in Future Power Systems. So a little preface. This work was conducted here at MIN Paris at the Center Persée, supervised by George Karimiotakis and Fabrizio Sossan, and associated with the Horizon 2020 project X-Flex Hydro. I will start today's presentation giving some context, then I will move to the objective of this PhD thesis, and then I will go through what they are the main contribution of this work. Finally, I will conclude and give some perspectives on future works. Now, let's begin with the context. The electric power system is traditionally operated with conventional generation that provides electricity and essential grids to the essentially ancillary services to the grid. In the context of the energy transition, what we want to do is to replace carbon-intensive and eventually nuclear generation with stochastic renewables such as wind and solar. The integration of these sources poses many challenges to the electric power system because, as opposed to conventional generation, stochastic renewables are weather-dependent, non-dispatchable, and non-controllable. So they introduce variability in the power supply at multiple time scales, therefore requiring more short and long-term flexibility for the system. Concerning, for example, quick time scales, one major issue is to maintain the grid frequency stability by balancing the power demand and generation. So there will be in the future more increased regulation duties from the remaining controllable plants. Now, what is the role of hydropower in this context? Hydropower is a form of renewable conventional generation, the largest source of renewable electricity worldwide, and in many countries, it represents a critical infrastructure for the electricity generation. Hydropower plants are dispatchable in the short term. They provide fast regulating power to the grid and fast startup times thanks to the lack of thermal constant. In some configuration, they can implement also energy storage, such as in the case of pump storage hydropower plants. Now, given that hydropower will be the only form of conventional generation, the future requirements of increased regulation duties, such as larger ramping rates, more frequent start and stop sequences, and enhanced frequency regulation, may lead to an increasing level of the fatigue on the mechanical component, and in the worst case scenarios, it may lead to failures. Another problem is that since most of the plants were built between the 50s and the 80s, the hydropower plant infrastructure is aging and it was designed with limited flexibility. So there's a need for a novel technical solution to assure reliable operation of these plants. In this slide, I'm going to show the most promising technology to extend the hydropower plant flexibility. The first one is the variable speed technology that consists in decoupling the grid and generator frequency for more flexible control. Another technology is the hydraulic short circuit, which is a technique used in pump storage hydropower plant to modulate the power of the pump by acting on the output power of the turbine. And then we have hybridization, which is the technology we will tackle today. Now let's move to the objective of this PhD thesis. We focus on hybrid hydropower plants. An hybrid hydropower plant is a conventional plant augmented with the battery energy storage system connected in parallel to the electric machine. The advantages of hybridization are first to reduce the regulation duties for the hydropower plant because the battery is injecting the power, and second, to increase the regulation capability thanks to the quicker ramping rates of the battery. So the question we want to answer is, how do we control an hybrid plant? This is a classical hydropower plant which is controlled with an hydraulic governor that takes as input a power or frequency set point, and it determines a guide vane opening to the turbine. In this configuration, we know how to deal with the control problem because what we have to do is to set the parameters of the hydraulic governor in order to comply with the primary and secondary frequency regulation requirements. Then we hybridize, and we have two sources that are different in nature. So the question becomes, how do we split the power between the plant and the battery while avoiding fatigue? So this is so we call this set point splitting problem. That is a relatively new research problem that so far has been addressed in the literature with empirical models. One existing approach is to apply a linear low-pass filter to the input frequency and then to give the filter a signal to the hydropower plant and to give the higher variation of frequency to the battery. Now, the advantage of doing that is that it's simple to implement. Linear low-pass filters are simple to implement. However, they are completely uninformed of fatigue issue, and therefore they can lead to suboptimal use of the battery. As a major contribution of this work, what we propose instead is a model-based control that is fatigue-informed and allows optimal use of both the plant and the battery. Therefore, the primary objective of this thesis is to develop a set point splitting strategy with guaranteed performance on fatigue reduction. Then we have a battery, so we know that at a certain point we have to recharge it, and therefore the second objective is to design a scheduler for managing the battery energy. Now let's enter the central part of the presentation about the real-time controller for fatigue reduction. So in this work, we focus on fatigue issues on penstocks in medium and high-head hydropower plants. In particular, penstocks are pressurized conduits that deliver the water from an upper stream reservoir to the turbine. The reason why we look at this particular component is because recent research has shown that the hydraulic transient due to enhanced primary and secondary frequency regulation can increase the damage on this component by 10 times compared to the case where no ancillary services are provided. So hydraulic transients due to regulation are well-known phenomena that I'm going to quickly explain with the following experiment we made. So we reproduce the penstock, which is connected to an upper stream reservoir, and then we implement a valve representing the guide vane opening. Before the valve, we install a relative pressure sensor to compute the head, which is given by the sum of two contributions. So we have Z that represent the elevation head, which is the elevation above the datum, and then we have the pressure head, which is expressed by the pressure measured by the instrument divided by the water density and the acceleration of gravity. Now, the experiment consists in fully closing the valve from a fully open condition. So let's see what happened with a short animation. So at the beginning, the valve is open and the head is close to the atmospheric pressure. Then we start closing the valve and the pressure rises up to a maximum value. Then the valve is closed and we observe a reflected wave that propagates through the penstock at the given time period, which is given by 2 times the pipe length over the wave speed. This reflection dissipates due to friction until reaching a steady state condition where the head now is equal to the static pressure of the water column. This phenomenon is known as water hammer, and it appears for rapid variation of the guide vane opening. Now, the generated overpressure are a concern because they induce stress on the penstock's wall. Now, to determine this stress can be determined as the force exerted by the water, which is given by the water pressure times the blue area, over the area subject to the force, which is represented by the 2 surfaces here in the figure. We can also express the stress in terms of head by replacing the pressure with the head from the head definition. Now, to go from the stress history to the service life of the component, let's consider the following stress signal where we can identify the cycle amplitude delta sigma. Then in this work, we leverage the stress life method to assess the fatigue based on the Wooler's curve or SN curve. So the Wooler's curve, represented here in the bottom figure, gives information about the number of cycles that a component can undergo at the given stress level. These curves are determined experimentally and they are reported in technical standards. Now, a curious and interesting fact is that for ferrous material such as penstock, there exists a value called fatigue limit, below which the fatigue won't virtually impact on the residual life of the component. So the intuition we have behind the formulation of a fatigue-informed controller was, can we design a controller that ensures that the penstock stress stays below this fatigue limit? To formulate the stress constraint, we consider again the stress signal over time, where we impose the following bounds. Then we obtain that the largest possible variation of the stress is given by delta sigma bar. Now, if we set delta sigma bar equal to the fatigue limit of the SN curve, then we can possibly avoid fatigue. Now, we can rewrite equation 1 using the head tube stress model from the former slide, and then we identify the upper and the lower bounds in terms of head. Then, assuming that we can model the head as a function of the controllable valve position, then we can formulate open loop stress constraint. Therefore, the question is now, how do we model this head? The behavior of the water within the pipe can be described by means of the conservation law of mass and momentum. Assuming one-dimensional approach, this equation can be represented by the following set of partial differential equations that relates the state variables in terms of head and volumetric flow rate with the geometrical parameters of the pipe and some constants. Now, the set of partial differential equations are converted into a set of ordinary differential equations by discretizing the pipe in a finite number of elements. Finally, we come up with the following set of equations that can be described with an electric circuit model where we introduce new parameters that are R, L, C as the hydraulic resistance, the hydraulic inductance, and capacitance. The equivalent circuit model of the complete plant then can be obtained by combining the penstock model, the turbine model, and reservoirs. In particular, the reservoirs are modeled as a constant voltage source. Then the penstock is modeled with a series of RLC branches, where each branch corresponds to a segment of the penstock. And then the turbine is modeled as an equivalent inductance accounting for the inertia effect of the water, and by a variable voltage source whose value is directly derived from the characteristic curve of the turbine that capture the relation between the state variable of the hydraulic machine. For example, in the case of a Francis turbine, the state variables are the specific energy, the torque, the rotational speed, the flow, and the guide vane opening. Now, these models are nonlinear, and the first nonlinearity arises from the dependency of the hydraulic resistance on the volumetric flow, and the second stems from the nonlinear behavior of the characteristic curves of the turbine. So we seek to linearize this model, and first we assume small variation of the flow, and therefore the hydraulic resistance can be considered as constant. And second, we approximate the characteristic of curve of the turbine by using a first-order Taylor expansion. Finally, we come up with the following linear and time-invariant state space model, where the state vector is represented by the flows and the heads at each penstock element, and the control input is the guide vane. Now, what is the accuracy of this model? So we perform time domain simulation, and we evaluate the error as the difference between the linear estimates and the output from the nonlinear model. This slide shows the result for the guide vane to head and the guide vane to torque linear models. And the major outcome here is that for small variation of the guide vane opening around the linearization point, the error seems acceptable. Therefore, this suggests the use of linear models in small signal applications. Okay, so now we arrive at the formulation of our controller, which is a model predictive control that takes as input the guide vane opening from the governor, and then it produces a new guide vane opening that accounts for the fatigue in the penstock. In particular, the MPC computes the head at all penstock element by leveraging the linearized model we developed, and then it constrains the head variation within the bounds that we discussed before. Then the new guide vane has to track the original guide vanes to set point to deliver the same regulation capability of the original plant, and this is expressed in sense of distance minimization. Thanks to the linearized models, the formulation of the MPC problem is convex, and therefore it can be solved with real-time requirements. Finally, the MPC is applied in a receding horizon manner, meaning that it is solved for a given time horizon, and then only the first element of the control action is applied, and then the problem is solved again at each time step with updated information and eventually linearization according to the operational conditions. This slide shows the result of applying the MPC at the output of the governor. We consider as a case study a medium-head hydropower plant providing primary frequency control, where we set the droop regulator to 2% to simulate future requirements of flexibility. The simulation results are from nonlinear equivalent circuit model of the plant, where we model the electric generator with the swing equation and steady state power angle model. Now, the bottom figure shows the guide vane opening from the governor, denoted by Y star in the blue line, and the guide vane opening from the MPC, denoted by Y dagger in the dashed red line. The bottom panel figure compares the head in the most critical penstock element due to the two control inputs. What we can observe here is that when the head constraints are not violated, the two set points are identical. And this follows from the formulation of the problem. So in particular, when the problem is unconstrained, the optimal solution is given for y star equal to y dagger. However, when the constraints become active, the guide vein produces a new set point that differs from the original. In particular, we can observe that the control action of the MPC resembles a rate limiter. So this suggests that perhaps considering a rate limiter-based strategy to reduce the fatigue may be considered rather than a filter strategy. Then we extend the formulation to the hybrid plant, and the requirement is again that the hybrid plant should mimic the behavior of the original hydropower plant. The battery set point then is computed as the difference between P star, which represent the power from the original guide vein signal, and P dagger, which is the power after the action of the MPC. Now, while the latter quantity could be accessed because it is physically realized, the first is not available. So we propose to estimate it with the guide vein to power linear model, which is referred to as twin plant in the block scheme of the figure. In this slide, I show the results of the hybrid hydropower plant against its conventional counterpart. So regarding the output power, we see that the red line, which is the output power of the hybrid plant, closely tracks the blue line, which is the reference power. So we can conclude that the requirement of controlling the battery to achieve the same regulation duties as the original plant is fulfilled. This slide shows the results on penstock damage. So to assess the damage on the penstock, we use the following methodology. So for each penstock element, we convert the head time series to stress. Then we apply a rainflow counting algorithm to identify the stress variation and their number of occurrences. Then by selecting an appropriate SN or Wooler's curve, we can determine the damage index, which is given by the number of occurrences over the maximum number of cycles at a given stress. Here, value close to 0 indicates no damage, while value near to 1 or larger indicates that the component is likely to fail. We compare the performance of the MPC against the benchmark controller, which is the first order low-pass filter, where we set the cutoff frequency of this filter in order to achieve the same regulation performance as the MPC in terms of correlation coefficient between the grid frequency signal and the power output. The results are expressed in terms of relative damage index, which is the damage index divided by the largest damage over all components and methods. The results shows that linear low-pass filter actually effectively reduces the damage along the penstock. However, in the portion of the penstock between 200 and 400 meters, where the damage is the most important, the MPC achieved a better reduction. Now, the second contribution of this work deals with scheduling the battery's operation. So far, we have considered the problem of how to split the power between the battery and the hydropower plant to reduce the fatigue in the penstock. Now we focus on the energy management of the battery. In particular, we want to formulate a scheduler that reads the current state of charge of the battery, and then based on energy and power forecast of the service to provide, it determines an offset power to either charge or discharge the battery. The objective then is to ensure that the battery has enough energy to provide the fatigue reduction service while respecting the power and the energy constraints of the battery. In this slide, I will show the classical formulation of the scheduling problem. So we start saying that the battery injection is given by two contributions. The first is represent the service we want to provide, which is given in terms of power forecast. Then we have F, which is the offset power that is responsible for charging or discharging the battery. So the classical scheduling problem seeks to minimize this offset power over a scheduling horizon such that the power and energy constraints of the battery are respected. Now, the problem with this formulation is that it considers static power constraints. These are an approximation of the true physical constraint of the battery under the assumption that the voltage of the battery is constant. However, in reality, the voltage of the battery is not constant, and the true physical constraints are actually the voltage and the current. So therefore, the classical formulation may lead to unfeasible schedules, especially in power-intensive application, like in the case of fatigue reduction service. So to show how this scheduler may fail, I will discuss the following example. So we have a battery, and we are at the current time instant, and the state of charge of the battery is 15%. Then at the next time interval, the battery is requested to discharge at its rated power. Now, because the energy and the power constraint are respected, the conventional formulation, so the scheduler implementing the static power constraint, which is referred to as scheduler A in the figure, initially won't give any offset. And then at time t equal 2, it will discharge at the nominal power. However, by doing so, scheduler A violates the current constraint. And the reason is that because at the low state of charge, the voltage of the battery is low, and therefore to deliver the required power, the current has to be high. So what we propose instead is to formulate a scheduler which includes state of charge dependent constraint, which is referred to as scheduler B in the figure, that at the time instant t equal 1, it detects the violation of the power constraint, and then it produces an offset to recharge the battery. Then at the time t equal 2, it discharges the power, but respecting the current constraints. Now, to formulate such a scheduler, the first step is to estimate the power capability of the battery. In this work, we leverage the voltage limited ohmic resistance method based on the following equivalent circuit. This circuit is composed by an open circuit voltage, which we assume to be a linear function of the state of charge, and then by a series resistance. So the battery of the power can be computed as the product between the terminal voltage V and the current. Now, imposing the real physical constraint of the battery in terms of minimum and maximum level of voltage and current, we obtain the following curves that represent the peak power capability as function of the state of charge. Now, an interesting outcome is that this envelope is convex, so we can rewrite the bounds as 4 segments that are linear function of the state of charge, and then we include them in the scheduling problem as linear constraints, therefore obtaining a convex formulation of the scheduling problem. So, before I said that the service to provide enters the problems in terms of forecast. So for the fatigue reduction service, the forecast of the energy and the power by the battery is given by the contribution from primary and secondary frequency control. Now, since these quantities are difficult to forecast because they are related to frequency deviation, what we propose is to replace them with the estimates of upper and lower bounds. So to find these estimates, the first step is to compute the battery power and energy contribution. So for example, in the case of primary frequency control, what we do is that we take historical frequency data and then we apply the same problem formulation of the real-time controller, but this time we simplify the model by neglecting the dynamics, and then we replace the MPC with the rate limiter on the frequency to decrease the computational time. Then the energy is computed by integrating this power over a suitable time interval, and the process is repeated for the secondary frequency control. The second step is to evaluate the distribution of the estimates and then to determine the prediction intervals by selecting symmetrical quantiles. Now we want to compare the two schedulers formulation, and the scheduler performance was evaluated during a period of 24 hours by simulating different scenarios of state of charge conditions. So in addition to fatigue reduction service, we also consider an energy intensive application to reproduce variable state of charges of the battery. The simulation procedure consists in the following figure. So at time t equals 0, the scheduling problem is solved for a given scheduling horizon. Then the first element is taken and is given to the MPC that at each second computes the guide vane opening for the plant and adjusts the battery set point. Then after 90 seconds, the scheduling problem is solved again with updated informations. Okay, this slide shows the result in generating a feasible offset power. So we are at the initial time step where the battery has the state of charge to 10%, and as additional service, we consider that the battery is requested to discharge at 50 kilowatt for 12 hours. Now, scheduler A produces a positive offset to just maintain the state of charge at the acceptable lower limit, which is of 10%. Then after 12 hours, the battery is requested to charge at 250 kilowatt for the remaining 12 hours. So the scheduler generates a negative offset to keep the state of charge within the limits, the upper limits, which are 100%, but at t equal 22 hours, it fails to comply with these energy constraints. Scheduler B, at the beginning, produces an offset power so that the battery is charged up to a state of charge level around 40%. Then after 12 hours, the offset becomes negative, but this time the state of charge upper limit are respected. This slide shows the result in respecting the current constraint. So we have in blue the current from scheduler A and in red the current from scheduler B. Then we have the current limits that are different in the two cases because they are function of the state of charge. And here the comparison consists in evaluating the number of violations of the current constraints, but also the average distance between the current value and the bounds. So the results here show that for a battery with initial state of charge of 10% in our case, scheduler A violates 18 times the current limits and scheduler B violates 5 times the current limits. So for different initial state of charges condition, we can draw similar conclusion. In particular, scheduler B achieves a less reduction of the number of violation of the current limits, and also a lower average difference between the current and the bounds with a lower variance. Now let's draw some conclusions and future perspective. So we start this presentation with two questions. The first was, how do we deal with the set point splitting problem? So the contribution in this sense was to formulate a fatigue-aware control for hybrid hydropower plants through a model predictive control. So we derived reduced order model of the plant to develop linear control strategies based on convex optimization, and we demonstrate that this model provides a good accuracy for the head and torque estimates around their linearization point. Then we propose a convex formulation of the optimization problem that was solved in terms of tenths of seconds, and therefore enabling real-time control implementation. The controller shows guaranteed performance in fatigue reduction on the penstock. In particular, compared to the low-pass filter, it achieved a damage reduction by 40% on the most critical component of the penstock. And finally, the hybrid hydropower plant achieved the same regulation capability as the conventional plant. The second question was how to manage the energy of the battery. So the contribution in this sense was to formulate a scheduler for power-intensive application. And then we include state of charge dependent power constraints into the scheduling optimization problem. And we demonstrate feasible schedules for the fatigue reduction service and a reduction of the number of currents limits violation by 30% compared to the classical scheduler. Now on the future perspectives. So one avenue which would be interesting to explore concern the fatigue modeling on the mechanical component. So in our study, we modeled the fatigue by leveraging the stress life method, but there exist many methods to assess fatigue that would be interesting to test. So in general, fatigue modeling is a very complex problem, but in recent years, there has been a development of new models such as machine learning or data-driven modeling or multi-scale models. And so I believe that considering also different type of approaches would be interesting to better prevent and assess the fatigue on the components. Then another track is concerns the battery modeling. So this perspective is twofold. On the one hand, we assess the peak, the battery capability by using a simple model of the battery. However, there exist many models that can be considered. For example, we can consider equivalent circuit models that are more detailed, that are can be expressed with the linear system of equation. Then we have extended Kalman filters that allows for a convex optimization. And additionally, we also have empirical models that can be expressed by convex function, such as polynomial models. On the other hand, we didn't consider the battery degradation in our problem, which is a really important topic. And in particular, battery degradation can be tackled with cycle-based models, such as in the case of mechanical fatigue. Another perspective concern is the extension to other types of plant. Here, the main challenge is to identify the critical component and then replicate the fatigue on that component to develop closed form expression of this. Finally, another perspective is to test the MPC in an experimental setup and to evaluate its performance, starting, for example, with hardware in the loop simulation. So this work has led to 4 publications, 2 in journal papers, 2 in conferences, and currently we are preparing other 2 journal papers. Thank you very much.
Okay, so thank you very much, Stefano. Thank you for keeping the time, and also thank you for the very clear presentation of the main outcomes of your thesis. So we are now starting the discussion, and we will start the discussion by giving the floor to the members of the jury. I will start by giving the floor to Professor Sedik Bacha. So please, the floor is yours.
Thank you, Mr. Chairman. I take the advantage of the first words to congratulate the candidate. Thank you very much, Stefano. It's very nice presentation, covering all the important points of your thesis. And it's very a pleasure to hear directly an exchange with it. Would be, I think, very worthy to exchange with you. I'd like to express my gratitude as well for your supervisors for the confidence they put on my judgment and my expertise. It's really a pleasure and honor to be with you in this jury. The subject tackled here is a very important one, really. Timely one, really directly connected to what is called the flexibility on its assets. It's very strategic today to develop the means of flexibility and the management, the energy management and power management related to. Then I think very interesting subject in general. Concerning, I'm thanking you for this opportunity to exchange. My questions will be very wide because the subject is interesting. It's more exchanges than an exam. It's not for me an exam, but I'd like to exchange and learn maybe from you from some aspects. My first remark is related to the fatigue, the criteria you choose, and the effect, hammer effect mitigation. You know, hydraulic plant, we have a lot of constraints. And the problem with electrical engineers, they are not well informed about these constraints, and the Graal, and the Graal is the best philosophical stone for research in this domain, is to include the both knowledge from electrical engineering and hydraulic engineering. And it's a very vast, very wide domain, especially for fatigue, for the constraints related to hydraulic plants, like cavitation phenomena. Many operating points must be avoided because they imply fatigue and so on. My question is very simple. Why did you focus only on this problem of hammer effect? Maybe there is a lot of possibilities beside this.
Okay. I thank you for the question, and I agree with you that there are so many phenomena that we can consider. The assumption of this work was to focus on the penstock, basically just because we identified this component as the critical component of the plant. So the assumption was, okay, we focus on what is like the most critical component, and we try to avoid the fatigue. Then I agree that other effects then can appear if we are like reducing the head maybe on the component, then we realize that there are other fatigue issues on the other components perhaps. But the other assumption is that we focus on the critical component, that in medium head is a penstock.
It's clear to me. It's just to know why this choice. The second problem, the second question is related for the modeling aspects. As I said, it's very critical because to put or to join electrical and hydraulic models, behavior models, is very critical aspect because we have problem with the modes, hydraulic modes, electrical mechanic modes, electric modes, and so on. Okay, then I was surprised that in the simulation models there is no information, or maybe it's just missing, about the electrical models which has been used not for developing control model, but to develop a deep simulation model. The electrical system is modeled by its swing equation. It's okay for mechanical aspects, but sometimes this swing equation can be connected to the power system stabilizers, which has embedded inside the whole control of the synchronous machine. This PSS, I don't know if it's embedded inside Simpson library. Have you used it or just missed it?
Actually, I replicate the model on MATLAB, but yes, yes, I use it. So, can I answer to the question?
The problem, you know, the power system stabilizer is operating on the range of electromechanical in the frequency response. Then it's very close to the mechanical modes. From what I say, it can change something. Maybe I don't know. It's just an open question. There is no trap inside this.
I acknowledge the importance of considering like more detailed models of the electrical machine. So this I agree with you. Yeah. So in future works it would be really interesting to develop like more complex. I totally agree. We choose 2-order models as a starting point, I would say, because we focus on the hydraulic transit, but it's a starting point. So then I also want to, as you said before, we have to distinguish between the simulation model and the control model. The simulation model, can be very accurate, and I agree. And the control model has this trade-off between the accuracy and the computational time.
But the question is really related to my concerns, actual concerns, because we are embedded in many works regarding the ancillary services, which rapid ancillary services provided by PSPs, and this is completely inside the project. Regarding the linearization, it's very clear. The explanations are very clear. The manner how to obtain an accurate linearized model and so on. I have just very small question in figures 2.10. It's a mapping of the errors, and you mentioned that you used the mean absolute error. It's good, no problem about that. But I have just one question. It's about the windows of the average operation. It's an average for a given period. And this period could be critical. Maybe if it's in very short time, from the instantaneous error to the average error, very flat, there is big differences.
This is a very good point. So the evaluation consisted in 2 steps. So evaluating this error for steady state condition, and then for dynamics for transients. So we impose a step, and then we evaluate the difference between the 2 models in this step. So I would say that perhaps it's a good point. The time we consider was the time of basically the transient, but was really limited to like just the transient behavior, not like until the transient is dissipated. So it was considered like a smaller window to assess this, because otherwise, as you said, it can be higher, it can be in different values.
can this time for this Windows can be correlated with your MPC controller, maybe regarding the horizon in Windows? I have an error. Okay, I have to assess this error. I have a controller, PC controller, with a given horizon, with sampling time and so on. And is it possible to correlate these two aspects? Or is there a link? Can we make the link? Make a link between this Windows for error assessment and the controller? You use
I think there is totally a link, because also the way how we set the prediction horizon depends basically on the transient of the water hammer. So there is a link between these two things. Yeah, sure. And I mean, the prediction horizon, for example, is assessed by considering the time the wave propagates. So, and we know how to assess this value because, as I showed before, the period of the propagation is given by an empirical formula, where the only, let's say, parameter to assess is the wave speed that depends on geometrical condition, etc. So you can set the prediction horizon this way. Yeah.
Thank you. Thank you. It's clear. It's clear to me now. Okay. And maybe I have one or two more questions, if the chairman permits. Thank you.
Of course.
Thank you. The most important question from my point of view is when you provide a service, ancillary services and so on, or if you have hybrid architecture, the main point for any optimization problem is to reduce the LCOE. I mean, the cost of levelized energy. For maybe I can use the PSP to provide a given amount of energy on power, but the main problem is to reduce this cost. Even the fatigue can be included inside the costs. Maybe is it possible to, if you start a new thesis, or you can supervise a new thesis as a doctor, maybe, how can we tackle this subject of reducing the running and the investment costs for a given PSS system with its batteries or a hybrid one? What are the main parameters? What would be the main variable decisions and so on? It's very big problem.
That is a very, very interesting question. Okay, so the answer is I would like also perform like an optimization, and where I would consider, as you said, the cost that are involved in this optimization, that are basically the cost of replacing the battery, the cost of replacing the penstock, the cost for maintenance, the cost for downtime, and so this can be formulated in an optimization problem, and then what you can do is that you can put some weights to like penalize certain costs, for example. And I want just to add that like in our thesis, okay, it's important to consider the battery degradation, and this is for sure future work. Yeah. In this work, in our work, we make an assumption at the beginning, also based on some results that we presented. So the power of the battery was a small fraction of the rated power of the plant. So we assume that the cost of the battery is really smaller than the other costs. So that's why in the first approximation, we didn't consider this cost. But I would do this, the first thing I said.
I agree with your approach. It's a pragmatic approach. It's normal. Okay.
Okay. Thank you.
Regarding the batteries, you know, some work on the same subject of hybridization of hydraulic plant, advised to use supercaps instead batteries. Knowing the problem is more a problem for rapid ancillary services, the problem is more related to power management system than energy management system, of course. What is your opinion about that? It's really an open question.
So at the beginning, I thought, yeah, why don't we put a supercap? Because the power intensive application requires really high levels of power for a small duration. So what I think is that nowadays, like the technologies of the battery are so advanced than before. So perhaps the battery can also be used for other services rather than just for fatigue reduction. So maybe it would be, yeah. So we can use the battery for other things. So maybe like also economically it can be like convenient.
It's
I don't know.
because we have been working a lot on this subject, and we build the setup and so on. There is many applications, really interesting applications with supercaps or battery, or a mix between batteries and supercaps and so on. But,
yeah.
Okay.
Yeah.
Just the last question now for the future. You mentioned hardware in the loop simulation. Do you have an idea the way to implement your controller in a PHEN or HEN setup, maybe by including maybe a power hardware in the loop? You know, there is many European contracts because we are embedded in one of them, which have the ambitions to develop the power hardware in the loop facilities for developing such controller like yours. What's your? Do you have ideas about how to build it? In what way? What could be the problems? What could be the challenges to build that setup?
Yeah,
it's
actually,
another open question. It's okay.
Yeah. I have because okay. I have because actually it was not presented in the manuscript, but we perform hardware in the loop simulation. And if you want, I can show you also extra slide that I made to. Okay.
If the chairman accepts.
Okay, so we actually perform hardware in the loop simulation, and this is the experimental setup we use. I also, sorry, I want just to say that this work was done by a master student visiting the PFL, Mattia Martini. So this is his work. I was just supervising. So this is the experimental setup. We have the dispatch, which is a grid composed by 2 voltages level with 6 connection nodes to connect groups of production. Then we have 5 synchronous generators with a rated power of 8 kilovolt ampere, and that are moved by a brushless DC motor that emulates basically the hydraulic turbine. And then for the measurement, we use the CCAM and we communicate via Modbus protocol. So the hardware is a loop simulation. Basically, what we did is to make a digital clone of the plant, which is basically what we did in the thesis. But then we made a Simulink model that was run with a real-time simulator, which is RTLab. And then this digital clone communicated with the physical, let's say, equipment that was this the motor and the electrical generator. So but the case study is the same as the thesis, and I can show you some results concerning the performance of the MPC. So the MPC again was actually run in real time. That was really interesting because so we have also the experimental validation. Oh no, what happened? It's gone.
It's gone, yes.
Okay, just a second.
This is a real-time presentation, of course.
Real-time
Okay.
So now I see my face.
I think. Thank you. Thank you.
But anyway, so we perform hardware in loop simulation. So it was.
I think we have
another
another
interesting.
specialist. Yes, we have another specialist with Mario. I think I let him developing maybe more questions about the system. I'm really thank you again, Stefano, for
Thank you very much.
these exchanges. I return the word to the chairman. Paolo, please.
Okay, thank you very much, Sadiq. So we are going to pass now to the second member of the jury that is discussing the thesis, Professor Mario Paolone. Please, Mario, the floor is yours.
Thank you, Joao. Well, first of all, I'd like to join Professor Baccia for the positive comments. I really liked reading the thesis and your work, and you have to be commended for the original and very relevant work, given the context of the role of hydropower plants within the European power system. So I can join what has been already said by Professor Baccia. Before starting with the question, just a tiny comment. On slide 7, you showed a picture of the Sayano-Sushinkaya catastrophe. I would be more careful to show this picture because this was an accident that was mainly due to erroneous design and operation of the plant rather than a fatigue-induced accident. So be careful about using this image. Don't do too much overselling, okay? Now, let's go to back to the technical questions. So in the electromagnetic world, in particular into the electromagnetic transient world, you know that propagation phenomena that are taking place in transmission lines are basically the same taking place into propagation of pressure into water conduits. So essentially we are solving the same equations, which are the D'Alembert equations. Now, in the electromagnetic world, when we have, let's say, a set of wave equations where the losses are nonlinear, like in your case, you have resistances that are function of the mass flow, what we have is that the propagation speed remains unchanged, because essentially the propagation speed is 1 over the square root of the product between inductances and capacitances, essentially longitudinal inductances and shunt capacitances. Now, what we do in the electromagnetic world is to say, okay, we use the Bergeron method, parenthesis, Bergeron was an hydraulic engineer, not an electric engineer. So we use the Bergeron method to analytically solve the wave propagation, and then we add lumped losses like lumped components. And these lumped losses can be also nonlinear. In the case of electromagnetic world, these nonlinear losses are essentially due to the CASSANO impedance, so essentially the impedance of the ground. Now, can you tell me why you opted for solving the wave propagation equations using a set of finite differences? Because this is like using a bazooka to solve a problem that can be solved analytically in a way easier fashion. Can you elaborate about your choice?
Okay.
I'm not saying it's wrong. What you did is numerically and computationally correct. There are no mistakes there. It's just that you're using a very complex tool to solve a problem that can be solved easily.
Yeah. But I mean, the choose of like equivalent circuit model for me was done because, first of all, I'm an electrical engineer. And so I was like to have like this the same formalism as the electrical circuit, also like enabling the implementation of the characteristic curves in terms of voltage sources, for example. At the beginning, when I had to make my modeling choices, I saw that there were other methods, but in terms of like representation, like in terms of representing them like a state space model, the electric circuit were the most like let's say the most how can I say, the one that provide good accuracy, but also good formalism, I would say.
Mm-hmm. In terms of computational complexity, do you have an idea of how much time it takes you to solve the wave equations?
I'm not sure, but I don't know compared to the other methods. In my case, like to solve the system was in terms of tens of milliseconds, we say, or less.
It's negligible, let's say.
Yeah.
Okay. So in this case, you can say, since the computation time is negligible, actually you can also use a method that integrates the equation in a brute force way, so you are closer to reality. Indeed, the method that I'm referring to, it's an approximation, because essentially it's adding the losses as lumped element after that you have solved the undamped wave propagation equations. Okay, fine. Let's move on. So I very much agree with your statement that was motivating your whole work related to the usage of model-based models, because using low-pass filters to essentially dispatch the signals of the frequency quantum reserve, we know very well that is an agnostic approach that will produce a suboptimal solution. So I very much liked your statement and the motivation of the whole work. However, as you know, when we use model predictive controls, namely controls that are relying on models, there is a drawback, and the drawback is the quality and reliability of the models. So there is a check that you have to pay. This check is this reliability of the models and the knowledge of the various parameters. Now, I'm referring here to the selection of the Euler's model, so the Magnus rules and your rainflow counting algorithm for the fatigue assessment. As you know, that there are different models for assessing the fatigue. Elena is here, she's a mechanical engineer, and she knows this subject way more than me. And one of the models that is used as a better approach is crack propagation. Now, why you haven't used more sophisticated models compared to the rainflow counting of the cycles, essentially using the Euler's model? Was it due to computational performance? Was it due to knowledge of the parameters of the fatigue? Can you give me a justification of the selection of this model?
Yeah, sure. But first of all, I would like just to show, like in this slide, we actually consider also crack propagation. So in the end we did. But the stress life method is a very simple method, I agree. It's also really widely used for like damage computation. The other, the thing is that fatigue modeling is really complex, and then there is no like a model that better approximate the fatigue, because there are so many variables that perhaps one method can be better for one application and less better for the other application. So crack propagation method is very widely used also for penstock fatigue assessment. The problem is that then you have, for example, to know like the initial crack size, then you have to perform like non-destructive tests. So it's really like complicated to assess these initial cracks, for example. And so, but you can make assumption as we did here for the hard-ended loop simulation. And we also found that using the crack limits led to less conservative constraints. But this was our case, so perhaps it can be also different.
Okay, thank you. Can we go to slide 34?
Sure.
Yeah, okay. So this is your scheduling problem. And essentially the constraints that you have here refers to the state variable of the battery, which is its state of charge, and also to the power, which is more a static constraint. Now, you may know that in reality, the constraint in power of the battery, it's a little bit more complicated than that, because in reality, the capability curve of the converter that here you're assuming to be just a parameter, in reality can be a function of the AC and the DC voltages of the converter. And this means that your S, your capital S, actually is a constraint that is dependent on the state of the battery and the state of the grid. So in this case, the problem can become more complicated and non-convex. So what are your thoughts about this issue? It's a practical issue. So if you try to implement this in a real converter, you may have problems of feasibility. Essentially, the converter trips because of this dependency of S with the AC and DC voltages. I'm telling you because we have this problem. We experience this problem in reality.
Okay. So, sorry, can you reformulate the question because it was not so clear to me?
Essentially here you're assuming that the capital S in the first constraint is just a constant number, right?
Yeah.
What I'm telling you is that in reality, the converter of the battery trips because this S is like a sponge, is a capability curve that has a bizarre shape, depends on the manufacturer of the converter. And this shape depends on the AC and DC voltages, okay? Now, since the DC and AC voltages varies as a function of the state of the battery and the state of the grid, you have a coupling between your decision variables and the constraints, making the problem non-convex, potentially non-convex. How would you solve this problem?
I'm not sure, but I think I would solve as I did in my thesis. So to consider state of charge dependent constraint, for example.
Okay.
Because I mean by considering true constraints in terms of really voltages and currents. I will do that, yeah.
Or another way you can do it is to solve a problem like this, and then in case the real constraints are violated, you try to recover the nearest feasible operation point by just projecting it. So, which can be more computationally easy to implement. Of course, this is suboptimal, but it's computationally very efficient. That can be also an alternative.
Okay.
Okay. On slide 36. Yeah, okay. Now, I like the whole development that they've done. It's very elegant. Very much appreciated the way you also implemented it. I have no doubt about it. Now, the only point that I would like to discuss with you is the model of the battery. You know, when we're talking about frequency containment reserve, we are playing with a bandwidth that goes from sub-second let's say, tens of Earths up to, I would say, yeah, tens of milliards, okay, which means tens of seconds in terms of time scales. Now, in this frequency region, if you consider the Randall circuit of a battery, you may fall in what we call the Z arc. So the Z arc is the medium frequency. If you plot the Bode diagram of the input impedance of the battery, this frequency range is where you have the first arc of the impedance of the battery. That unfortunately is located really where the frequency component reserve is acting. So this means that here you should add an RC circuit in parallel in series to the resistive model, which can be still treated in a way that you did, like Fabrizio, for instance, showed in one of his papers. Why you didn't do that? I was a bit surprised. Why you choose this simple model?
I think it was like just to show that just by implementing a simple model, the scheduling problem can change, and then you can take into account of the state of charge dependent constraints. Okay. It was like, I think it was just an example.
I see. Okay, this was a justification. Okay, fine. Very last question. How would you size the battery? Because now you're assuming that the battery has a given capacity in energy and power, okay? But then you can use your model to say, okay, what would be the optimal size of the battery such that I can perform my service? So have you thought about how to address this question?
Yeah, I mean, yes. So to size the battery, what I would do is to like evaluate the power and energy needs for this service as I did a little bit. I mean, I mean, I estimate here the forecast, but I can also estimate like the energy and power demands required for the battery for the secondary and primary frequency regulation by using like historical data or set points of secondary frequency regulation, and then I can size the battery based on that. Okay. Yeah. In any case, the optimization problem wouldn't change. Also, like in my case, I consider a battery that was not optimized for this service, and the problem was also still the same. Yeah.
Okay, that's very good, because eventually, if you want to sell your control to an operator of a hydropower plant, you have to sell also the sizing of the battery, because the guy will come to you and say, okay, how big should be this toy,
Yeah.
And you have to provide this answer. Okay, good. For me, that's all. So I leave the floor back to the chairman. Thank you.
Thank you very much.
Thank you, Mario. Thank you very much. So we are going to proceed, and the next member of the jury to intervene is Dr. Elena Pagnoni. So please, the floor is yours, Elena.
Thank you very much. Hi, Stefano. First of all, thank you very much for your presentation. That was very clear from my perspective, and can just rebound on Professor Paolone and Professor Bascia about the quality of your PhD thesis. But I truly appreciate it. So
thank you.
I have a few questions. So as Professor Paolone already anticipated, so my background is more on mechanical engineering. So my questions will be more related to that part of your work, which is anyway a very important work for the field that graves perspectives also from, let's say, the hydraulic point of view of how to use those hydraulic machines and hydropower plants. So the first question I will have is about the values of the stresses. So in the slide 20, you've shown the Wheeler curve. And so in order to apply the rainflow counting algorithm, exactly. Yeah. And then I didn't really see an analysis going through those stresses values, but I only appreciated that through the evaluation of the damage, which is the performance indicator you selected to evaluate. However, since other methods do exist and the rainflow counting algorithm is normally, let's say, considered as a quite easy way to assess the fatigue in whatever context through a statistical approach, but generally speaking, is not considered the most accurate one. So with this in mind, so knowing what are the stresses that you actually would be able to reduce through your method would allow to understand better the results that you could achieve with this methodology, either with only the predictive control method without a battery and with a battery. Can you tell me in terms of stress cycle amplitudes where we are in this diagram?
I mean,
are we really can we really approach the infinite life? Are we already actually maybe in the infinite life for some cases?
So in my case study, because I also consider like more like future requirements of flexibility. So it was like hydraulic transient were much more important than normal cases. And then I just consider primary frequency regulation. So there are other services that perhaps can induce other stress that are higher. And yeah, I mean, so in our case study, there were cycles that were upper the fatigue limit. That's why we constrained under the fatigue limit. One thing is that I want to also clarify is that under the assumption that we constrain the head under the fatigue limit, in the result we should have that as a result that no fatigue actually is in the penstock, because if we consider infinite life, we don't have fatigue. What we did in reality is to consider the slope, and then we consider another slope we consider another curve with a different slope. So we have residual fatigue, so we have the stress that actually contribute, and they are not giving infinite life to the penstock. But yeah, we had some cycles that were above the fatigue limit. I would say not so high, but for primary frequency regulation at least.
Yeah, and my question leads to other things. So before, because in the previous slide, or maybe to before, you show the phenomenon of a water hammer that do happen when you close the the valve. Mm-hmm. And then the study that you do related is to the guide vanes variation, which is not the same component, and of course is very different to the effect of changing the angle of the guide vanes on the head in respect of this strong water hammer that do happen, for instance, either in an emergency shutdown or where you have a sharp variation, so or a sharp closing of or opening of a valve. So the other question would be is, did you consider both effects? So did you consider both cycles related to the on and off of this valve and the guide vanes opening variations, or did you only consider the guide vanes opening variation? And also, if you have an idea about the damage that both components position variations will lead.
I just consider guide vane variation. I didn't consider like really fully closing, fully opening conditions. But I mean, so for what I understood, like perhaps the fatigue is most critical during secondary frequency regulation, because there you have a really big step of set point, a power set point, that may lead to larger opening of the guide vane. Then it's also true that usually the guide vane opening is already limited by the rate limiter of the plant, and also because of the servo motor dynamics. But still, in some condition, you can have like stresses with the guide vane openings, even if, because the rate limiter of the plant is set to respect the static constraints of the limit. So the limit were applied at the beginning when the plant was built. Then with new operations and more like, more enhanced frequency regulation, we can also have stresses that are above these limits.
Okay, and thanks. And the other question that comes out from the previous question. So as you mentioned, you do have a damage even with the MPC. At least that was the results that you present both in your thesis and during the presentation, which is clearly lower than if you don't have any fatigue informed control, or if you have a simple filter with a dead band. So my question would have been, so is the MPC failing to respect this infinite life condition on the sigma, or if not, then probabilities would be, say, your answer, and so for this I will ask more explanation. How did you consider then the second slope? What was the criteria so for you to choose instead of having an horizontal line with a Euler curve to have a different slope of a curve?
Yeah, as I said, I consider a different slope, and the slope was set. So the slope of the first curve usually is called a Baskin equation, where you have this term that is the exponential, which is m, which is equals to 3 usually. And then for the second slope, I consider m equal to 5, because I saw in the technical literature that sometimes for ferrous material, they consider these changes of the slope. So this is, of course, was like considering fatigue, infinite cycles would be like a really weird case, I would say, real, because I think it's not really the case in reality, because these curves are not so how can I say, are not so detailed.
Yeah, well, those are valid for specimens, of course. Then when we have imperfection through the material of the components, this is typically what industries assess, and that's why those are less accurate, because those are based on statistics. Okay, so actually you didn't take this curve, but you took one with a slope. And is the MPC always successful? So according to the definition, I would expect then that the MPC is able to keep the stress level lower a given value, which is so in the second slope. So has a lower let's say, rate of damage, if we can call it in that way. Was the MPC successful in keeping this value, this delta stress, let's say, always below this set?
No, and the reason is that is because of errors in the linear model. So sometimes it doesn't really, it's not always accurate because of these small errors. But in general, what you can do is also like to consider a sort of slack in the head constraints, so you can like consider this effect in your constraints. But yeah, there are some errors due to the linear model, of course.
Okay. Thank you. And so my last question, you mentioned in your conclusive slide that other models could be used to predict the stress, and one could be, for instance, based on artificial intelligence and machine learning methods. So I think one of the strengths of your work is that actually how you define the stresses in a way that you can actually fully exploit it into an MPC model, because you do have a clear model, and it's not a black box method that you use to assess this damage and the stresses, so the delta stresses, which is what is entering actually in your MPC. How would you do that with a machine learning method predicting the stresses?
So I I don't know yet because I'm not so familiar with machine learning methods, but yeah, so I don't know. I will see. That's why I'm curious to test other different fatigue methods, because actually then I developed the interest in this topic, also the fatigue modeling, which is really interesting. So perhaps I will consider like yeah, artificial intelligence for future works. Yeah.
Yeah, because that, I guess, would add quite an important complexity, which is you don't know anymore what's fully behind your problem model of stress.
Yes, yes.
Because then maybe you gain accuracy, but you lose a bit the capacity of defining through quite analytical equations what's behind the stress modeling. So I guess then it's very likely that your problem is not going to be convex anymore, as you would need to model the stress with maybe some polynomial function, for instance, to get fitting with the results of a machine learning prediction that could add degree of complexity, of course, to your problem. It was just a curiosity to see if you thought a little bit more about how this could work and be coupled to the method that you developed. But thank you anyway. So that were my questions. I give the floor back to the president.
Thank you very much. Thank you. So we are now going to pass the word to Professor Veja Yang. So the floor is yours, please.
Okay, thank you, President. Thank you for your nice presentation, Stefano, and your two supervisors, Professor Georges and Fabrizio, for inviting me to your PhD defense. And it's also, I'm very happy to have this seminar with other professors from our jury members, and also listen to your questions, and it's all of them are very good, and I have also learned a lot of new things. Okay, so for the PhD work, I think this is a quite important topic. On the one side, it is important work for enhancing regulation performance for power grids. But at the meantime, on the other side, for our hydropower, for our power plants, power sources, the fatigue problems and adverse influence are also quite important. So the coordination between power plants and the power grids are also a key idea of my work. So it's I'm very happy to be here to give my comments and some of my questions. So then I will give some of my questions as follows. The first one is that this work deals with the control method, right? As I know, we have our field have a lot of studies on control theory and how to control the power plants, how to operate our units. There is a general question I'd like to ask, especially from if we read different publications from literatures, there are too many different methods and new methods. Okay, so for the method in your work, the MPC, how is the feasibility and challenge for the real implementation in real power plants? Well, it causes new problems like instability or reliability problem for the controllers. So this is a general questions. Okay, so this is my first question. Thank you.
Okay, thank you very much for the question. Concerning the real life applicability, so as I shown, we performed some hardware in the loop simulation where we saw that the performance of the penstock were good, so we were happy with that. And about like the stability, we didn't perform any analysis, of course. I mean, we didn't perform any analysis, but if something that I think, and I think I explained maybe, is that since the action of the MPC resembles a rate limiter, this is a good outcome for the stability of the controller, because the rate limiter action is stable for definition. So yeah. And so I don't know if I replied well, but the challenges are for implementing the MPC in real time is that it's solved with the real-time requirements. So there are many things that you can consider, like the prediction horizon, the accuracy of your models, and then also the communication between the controller and the physical equipment. And in our case, it was like we achieved this real-time implementation. So yeah, I can tell that.
Okay, because previously I also had some studies on filters or hydropower plants to reduce the wear and tear or something. And as you say, as you said just now, the MPC likes a rate limiter. Actually, it is also a non-linear factor, but I think it's somehow better than backlash or something, I think. So it's maybe the influence and the stability issue deserve some more studies. It's just my suggestion. And okay, so let's move on to my second one. So I'd like to ask the question about battery, but the previous jury members have also asked, so how is the capacity something? Okay, so I think I can skip this, but I'd like to ask regarding the battery, what's your opinion on the potential disadvantage? Do you have something in mind? And also we have some problems on the some questions regarding the investment, the economic effect, right? So are there any bad sides for adding the battery to the hydropower plant? Thank you.
Thank you. Yeah, I mean, for the so if I well understood the question, so the question was about the like the cost aspect on the battery size, is it? So yeah, so the battery was for reducing the fatigue. In our case study was the power that the battery had to provide was a small fraction of the nominal power of the plant, which was a medium hydropower plant, which is like a huge, big plant. So the cost of the battery is really smaller compared to the other costs of the plant. So what I suggest is that, yeah, perhaps we can also use the battery for other services to like benefit from the cost of buying a new battery, for example.
Okay, so the next question is regarding the working conditions of hydropower plants. So for the new control method, how are the performances for primary frequency control and the secondary frequency control under your control method? For example, the MPC or adding a battery. Are there any differences in different regulation performances?
You mean with the hybrid hydropower plant to compare with the conventional plant? Yeah,
no, sorry. I mean, in your thesis and the presentation, the workload, the load cases, the working condition, I think it's mainly for secondary frequency control, right? You have just to change the power set point and follow the power to balance the like the wind and solar or something. I mean, if we regulate our hydropower units in primary frequency control mode or secondary frequency control mode? Are there any differences?
Yeah.
Under your control structure? Yeah.
The main difference is that when we are considering the primary frequency regulation, usually we work close to the linearization point of linear models because the set point of frequency doesn't vary too much. When we consider secondary frequency control, then we have to re-linearize the model because the change of set point leads to different working condition of the plant. So we have to re-linearize the model, and we can do that like by using lookup tables, for example. So we don't have actually to compute the linear model in real time, but we can extract the data from these lookup tables.
So, okay, for these two kinds of services, okay, let's say services or working conditions, did you compare the results, I mean, the advantage of your method? So what kind of services did you think is better for using the new method, for using the hybrid units? It is better for primary or secondary frequency control?
I think it's better for both. I mean, there's no one service that I would consider like to be the better suitable for the battery implementation. We in the work we focus more on primary frequency regulation, I have to say, but the fatigue issue from secondary are more severe. So perhaps in both cases is important.
Okay, yeah, but I think you have not have the detailed comparison for these two services, right? Because I do not say this.
So, what? Sorry?
Did you have the detailed comparison in these two different conditions?
No, I don't. If I have some results about the two services.
Yeah, because
no,
you have. Yeah. Please continue.
No. Please.
As I'd like to let's see. There is a figure, I think, in your chapter. It's a figure 3.1. Okay, figure 3.1 in your thesis.
Yeah.
This is the comparison. Okay, for fatigue due to different conditions. Okay, different cases, right? Like in the primary or secondary control. Yeah, 3.1.
This one from
from
the literature.
Yeah,
this one from the literature.
Yeah, but did you have some comparison?
No, I didn't perform any comparison between the two. But what I believe is that the damage here is arises mostly from the secondary control.
Okay, yeah, thank you. So just now you mentioned the linear model, right? So I'd like to ask for this. So for the linearized model, this is also a general question, okay? So how is the applicable range? So for example, what's your opinion? For example, 10% or 5% or 20%? Do you think within which range the linearized model is good, can be acceptable? Okay.
Yeah. So the linear model is valid for small variation. That means like in order of 5%, I would say, of the guide vein opening around the linearization point. And then I would suggest relinearization.
Okay, great. My next question is also regarding the SN curve. I think just now Professor Anina also asked this, but I'd like to also ask you about this problem. So because the SN curve you have shown in the thesis and presentations, I think it's also from the publication, from the literature, right?
Yeah.
So how is the practical performance? I think you mentioned in future work, but do we have some initial study or comments on the practical performance of the SN curve, where it affects the results of your study? I mean, different SN curves, how is the influence? And because I think it is related to different materials and different conditions, right? But normally, when we do the study, we just use some SN curves from the literature. So will this affect our study results?
Yeah, sure. Yeah, the point is, for our study is like to choose like the good SN curve, which by the way is an input of the problem, and this curve can be like chosen by, of course, the material, but also the conditions of the material, the temperature. So there are many factors to choose the appropriate curve, which is something that the expert should suggest, perhaps. And then what you can do also in another approach is to really make some measurement, like non-destructive measurement on the components, like to evaluate the cracks in the material, and then based on that you can also choose other curves that are more suitable. So perhaps you have to perform some measurements if you want something more detailed.
Okay, my last question is also an open question. I'm also very interested because I have heard some reported cases for hydropower plants adding battery, okay, the hybrid solution, okay, in Germany, in Sweden, and also in the company Andritz Hydro. Do you have any comments, or did you heard about this? Did you do some investigations, and how are your comments? Because I have read something from internet. Yeah, they have also doing this study. Yeah.
Yeah, I did some investigation, and what I found was like really preliminary works, I would say, like evaluating like how to split the power was like the common problem. And then, as I suggested, the solution was like to apply filter or this stuff. Or also, like the other requirements was to assess if the hybrid plant comply with the primary and secondary frequency regulation service requirements. So this is what I found in the literature so far. So really preliminary stuff, nothing about the control. That's why I think it would be a good contribution, my work, for the literature.
Okay, thank you. This is all for my question.
Thank you very much.
Yeah.
Okay, thank you very much. So according to what we have discussed, I'm going to assign some time to myself and to make you a few questions. I should say that I have not many questions, because the fact that being one of the last members of the jury to intervene makes that all the other members of the jury already asked the questions that I have here in my list. Anyway, I still have one or two that I would like to ask you. So if you go to slide number 27 or 28, I suppose both can be used for the purpose of my question. Yeah, that one, that's okay. 28. Okay, so I understand the way how you have formulated your problem, and mainly the fact that in your hybrid formulation you had interest in sharing the output of the governor in order to share it with battery and the turbine of the hydro plant. But I would like to ask you that, okay, let's suppose that you don't have, in the first stages of your research, that's what you have done, but you don't have yet the battery there. Then you would have only the governor followed by the MPC block. And then my question is that in that case, would you consider also the possibility of replacing the governor by an MPC control approach alone? Have you thought about this?
We thought about another strategy, actually, I think was in the annex, another strategy to reduce the fatigue by replacing, the governor. So basically it was like based on transfer function model of the plant, and we imposed the same condition as the MPC. The only difference is then it was imposed in another way. In the MPC was imposed like a linear formulation, etc. And so, okay, I think that perhaps replacing because the governor is something that is installed in every plant. So like to replace the governor, to implement another controller would be like not easy, perhaps, and be the operator would not agree. And so
I understand. I understand the point. My question was that wouldn't that be, I mean, interesting from even from the theoretical point of view, just to see how performant would be that approach regarding a conventional one. That's the idea. So what do you think?
I think that then, like in the case of the MPC, we have to formulate like we have to model the head as a function of the frequency, for example, or the power. So we have to develop two models, and in this case, we are just the head dependency on the guide vane opening. For example.
I understand. But okay, so this, theoretically speaking, that would be also a possibility. Okay.
Sure.
Okay, so I have now a question for you. This is much more related with future work, and this is also related with the fact that myself, I had a few years ago a problem to deal with. That was so the deployment of large scale, large deployment of renewable power sources like wind power and solar PV generation in islands, and mainly in one island in Azores, as a matter of fact, in two islands in Azores, and so the idea was also to build hydro power plants, but the problem is that in both cases the penstock was a very long penstock, so meaning that the water starting time was very large, and when we were operating the power system of the island with let's say configurations where the hydropower plant was relevant, was playing a very important role, we had instability phenomena on the system. So how do you think you could also deal with such problems of having instabilities from the side of the power system? And in this case, how do you think that the MPC should be capable to deal with such situations? What kind of additional modeling would you have to include to deal with this in order to have a response not only from the hydro plant, but also but mainly I would say mainly from the battery, because at that time the idea we had was to install a battery aside the hydro plant to respond to the fast dynamics, while the hydro plant was responding to the slow dynamics. Okay, so Do you think this would be possible also to be done using the MPC and trying to find out the right set points for the battery and the hydro plant?
This is very interesting question. Thank you. I think that as far as we can like somehow model this phenomena and try to formulate somehow a sort of a model that we can include in the MPC, I think it is possible. I cannot like give a straightforward answer, but I think so.
I also think so. And of course, this is not an easy answer for a difficult question, but I also think so. And I think that the approach that you followed could give some clues, some interesting ideas in order to, how to deal with this. Okay.
Thank you.
Thank you very much. Thank you. And for my side, it's all. I don't have any further questions. Okay, now I'm going to switch to the job of being the president of the jury. And I'm going to pass the word to your supervisors. Okay. And I suppose the first one, I have it here, to intervene will be Fabrizio.
Yeah, hi, thank you.
Please,
so
the floor is yours.
Can you hear me?
Yes, we can.
Yeah, okay. So thank you, Stefano, for a very nice presentation. And also I would like to thank all the members of the jury for being here. So thank you, Beja, thank you, Mario, Sadik, and Joel. It was very nice to have your feedback on this work. And Stefano, well done. Congratulations. I think the presentation was clear, was well structured, and I think it followed pretty well the structure of your manuscript. I just want to say that I think you've done a very good job in these years. I think also there was the pandemic situation that made things a little bit more difficult, but I think you managed very well. You have been you are an independent thinker somehow, so you are capable of somehow analyzing and breaking down the problem in a way that I appreciate. I think that there are like very nice, ways to continue this work that you have done. There are very interesting perspectives. Many hydropower plant operators are interested in the job that you have done. So I think it's I think for me this speaks in favor of the quality of your work and the interest of the topic. So congratulations again, and I don't have anything else to say. Thank you.
Thank you, Fabio.
Okay, thank you very much. So the last intervention, last but not the least, George, the floor is yours.
I would like also to congratulate Stefano for the very nice presentation. It was very clear. Thanks also to the jury for very, very interesting discussion that went to quite high detail and gave a lot of ideas, additional ideas to the perspectives actually, and definitely this work can be continued. We know also that similar work is of high interest not only for hydropower plants, but there are also research works to develop similar solutions for nuclear power plants to hybridize with batteries so that they can have higher flexibility in scenarios with very high renewables. Because these were designed also to operate in a similar way as base loads, etc., and to deal with lower variability from the power system. So this, if we consider this and the fact that similar solutions could be developed, we can imagine that there can be a high impact to the industry actually for this work, and it's very interesting to continue to these directions. So with this, I would like to thank. I agree that there were challenges, like a big part of the work was done during the pandemic, and Stefano could not necessarily profit also from the interactions, face to face with X-Flex hydro project, which was a big project actually. But anyway, I think the contributions to this project also were valuable through this thesis. That this also enhances the potential for impact. So we are very happy for this, and I would like to congratulate again and thank the jury.
Thank you, George.
Okay, thank you, George. So thank you very much to all the members of the jury. Thank you also to Stefano for this nice discussion. And so the jury is now going to deliberate and is going to meet in another session, different from this one. So afterwards, after the deliberation, oh, sorry, I have one, I was missing that. I had to ask if someone in the public, in the audience, has any question to Stefano.
Okay.
Nobody has questions.
Nobody has questions.
From our side, no, because there is a condition that the audience they should have a PhD, and here we have mainly colleagues of Stefano. But
Okay.
I don't know from the people connected, so probably not.
Okay, yes. If also the audience includes not only the in-presence people, but the virtual attendees.
I think I have two friends with a PhD in the audience.
Okay.
Okay. So if there are no other questions, now in fact we are going to stop here this session, and we will be back after the deliberation in a while. Okay.
Okay.
Thank you.
Thank you very much.
Thank you very much to all of you, and we will continue in a few minutes. Thank you.
For the announcement, after we put display the faces, because we'll take some photo here. So when we take the photo with the jury.
So this is the manuscript.
No,
So
not
the first page?
The first page of your presentation. Sure. But you come on this side and between the wall.
Yeah, sure.
Giulio!
Com'è?
Perché non mi hai fatto domande?
Perché non ci capisco un cazzo.
Mica, beh, tra l'altro, mentre stavo parlando, c'era una discussione, ho visto la tua faccia comparire sullo schermo. Minchia come se la sente.
Lore mi ha detto che si è collegato, però secondo me aveva troppo paura di essere visto e si è scollegato subito. Però mi ha detto che stavi bene.
Invece Tullio non si è cagato addosso perché...
Lore,
Io
sei...
guarda, sono qui con le cuffiette stamattina. Vabbè, comunque com'è andata? Cioè, come sei contento?
Sì, sono contento, no, è finita, minchia.
Ottimo.
Tutto questo, tra l'altro, penso che verrà registrato per sempre. Devo stare attento.
Sì, è vero, è vero.
Grazie,
Sei
grazie,
come
ti
sei
ringrazio live.
Tipo il fatto che ti chiami Cabneri.
Vale però non si mostra, Vale.
Raga,
Vale,
io
fatti vedere.
sono al
Dove
CNR,
sei?
aspetta, sono al CNR. Aspetta, vediamo una... Aspetta, come cazzo si fa?
Riesco a gestire gli speaker.
Ecco.
Ecco.
Che può gestire gli speaker.
Eccoti.
Beh,
Wow.
No, la c'è tu 2 volte. Ah no, c'è Vale.
io non mi vedo.
Non mi vedo.
Tra l'altro il momento
Grazie,
delle
ragazzi,
domande... Io ero a Piotti, stavo venendo da lavoro, però ho seguito lo stesso, il bus, tutti i modi, mentre ho fatto colazione, tutto. Nella mia routine mattutina non c'è partita la cagata, però peccato.
Questo Vale sai che rimarrà negli annali delle cold mine.
Quando tradurranno questa conversazione.
Cioè, viene caricata sul database della Sorbona, cos'è?
No, Vale, è su YouTube.
Ma io voglio cercare di... Cioè, io continuo, perché sono col telefono, continuo a vedere la tua cazzo di slide. Ecco, ma cosa sbrani?
La focaccia di Priano.
Cioè, è una sorta di rituale.
Cioè, capito? Non la focaccia di Priano. Vabbè,
Cioè,
comunque, grazie ragazzi per esservi collegati, lo apprezzo un casino.
No, ma io non so perché, bene che era oggi, perché venerdì io sono incasinatissimo, ma oggi tanta roba, quindi...
Sì,
mica,
Vale, lo
ero
so,
lì...
mi hai scritto dei messaggi 2 volte.
Bello.
Dai, non ti sentiamo.
E abbiamo perso. Ma Ste, quindi sabato al forchettone?
Stefano, can you hear me?
Dai, Bishop.
I tried to call you on your phone. I tried to call you on
I was defending the thesis. No, yeah, sorry, I didn't see the phone.
It's
Ale,
you know it.
Yeah.
This is already on YouTube, you know.
Yeah, I know.
Somebody needs to switch off the YouTube video.
Somebody with Laurent, but it's gone, so I don't know how to do. So we record everything. Also me rolling a cigarette in a moment.
Can you hear me?
Yeah, I hear you, Bishop.
Hi.
Tell me.
No, I know. I was following you on YouTube, but now you are eating and it is being shown on YouTube.
Yeah, I know.
It's live that you are eating. I
know. It's how I make the followers, you know, just eating on YouTube. And then I have so many followers. By the way, thank you, Bishru, for the connection.
No, I was actually I had some appointment this morning, and I was in the bus and I was following your defense from YouTube, and then I just have like half an hour before I'm in the office. So
it's okay, thank you anyway.
Just now I got connected. So yeah, the presentation was nice. It's good slides. Yeah. So when is your deliberation? Probably in half an hour.
In few minutes.
Few minutes, all right. Okay. So you're gonna stay in Sofia Antipolis right today, or you will go back?
I don't know.
What's the plan?
Perhaps we go to the beach and then we go back to Genoa. I don't know.
When? Today, tonight, or tomorrow? You're gonna stay tonight?
Today.
Okay.
No, facciamo una mensa.
Okay, Stefano, we talk later. I think you are a little bit
Ciao.
tired right now. Yeah. Ciao, ciao.
Yeah, ciao,
See you later.
Michelle.
Bye, bye. Take
See
care.
you.
See you. And congratulations in advance. Okay.
Thank you very much.
See you. Bye.
Comunque Tullio, sì, andiamo a spaccarci al forchettone sabato.
Ottimo.
Cioè,
Non ci sono mai andato io,
Ma
penso.
No, è bello, è bello. Bel posto.
Tanta roba. È un'ottima scelta, cioè da quello che si intravede dalla foto. Abbiamo andato,
Abbiamo fatto
sembra
il
il posto
compleanno di
giusto.
Mag, abbiamo fatto il compleanno di Mag l'anno scorso.
Allora si vede che non c'ero.
No, non c'eri. No, però dico per dire che è stato interessante, cioè l'abbiamo scoperto.
Ottimo,
Grazie a
ottimo.
te.
Ma sembra, è una di quelle trattorie un po' cioè mezze fuori città.
Sì, dove ti sfondi, cioè.
non
Tipico.
andate a Drago Bianco. A Shanty House. Con un gran turbante.
Va bene, raga, io vado a fumarmi una siga.
Ma,
Vai,
sai,
vai.
ma dove sei di preciso? Io tipo mi sono sciolto questo dettaglio. Sei in
Sono in
Svizzera? sei a
Francia,
Sottile?
sono a Nizza.
Ok. Sei dovuto andare lì. Ok.
Sì, ma non c'è
Per un
Almeno
attimo
per la
non si vedeva.
difesa.
Almeno
nessuno.
almeno per quello.
Almeno
C'erano
per quello sono andato.
I cartelli wanted, Stefano. Dove cazzo è finito?
Basti.
Come
Quindi
funziona?
adesso fanno la delibera, cioè ti fumi una siga, aspettano che finisci la siga e poi ti deliberano.
Esatto.
E
E
basta, dura
poi
poco, no?
ringrazio tutti e poi tanti saluti. E poi si va a mangiare.
Va bene.
Ok. Dai, allora ci vediamo tra poco. Grazie ragazzi. Voglio bene.
Bella,
aspettiamo il festeggiamento qua.
Io parlo con Vale e tutto quello che diciamo rimarrà per sempre negli annali.
Sì, no, infatti, ma si può smettere questa...
No, perché il tipo che può smetterla non c'è adesso, è tipo è uno dei prof.
Vabbè, andiamo un attimo.
Ok.
Che
Vabbè,
bella
comunque
casa.
Vale, com'è?
Ma c'è anche una terza persona che viene da Monza.
Aspetta, se nel frattempo loro arrivano.
Esatto.
Beh, ci dite se arriva qualcuno.
Se arriva qualcuno fate tipo finta di essere morti, tipo frizzatevi.
Sì, esatto, facciamo così, va. Grazie.
Ti scriviamo, diciamo che stai doveva fumare la siga.
Tu, Tullio, ti trovi a Londra o Parigi?
Parigi, sono nell'ufficio di Giulia, arriva il
Ah.
soffitto.
Ma che
Si vede.
Madonna, ufficio personale.
Sì.
Sì, che è bello, grande. Tanto puoi stare in remoto, no?
Sì, oggi sono venuto qua, ma in realtà per motivi, cioè di solito sto a casa. Adesso abbiamo, te l'ho detto, Vale, che abbiamo comprato la casa con Giulia.
Ah no, questo non lo so, perché so che ce l'avete fatta, delle cose vostre. Diciamo che rimaniamo un po' per non registrare tutti i cazzi.
Tutti i cazzi nostri in diretta mondiale.
No, sono contentissimo. Addirittura ho comprato casa lì, sempre
Abbiamo comprato casa.
Parigi.
Sì, esatto, lì praticamente dove eravamo prima, poco lontano.
Grande.
E poi appena il tempo lo permette, ma in realtà non c'è nessun motivo di aspettare. Quando ci avete voglia di fare un passo con EasyJet o con Vueling che volano sull'aeroporto di Orly, di solito se uno lo compra in anticipo con 50 euro fa andata e ritorno.
Ma sì. Cioè ci starebbe, io penso non sono mai stato a Parigi, mai. Quindi sarebbe un'ottima... Non ho scuse, appunto. No, è tipo andarci così per vacanza, volevo sempre trovare un motivo per andare.
Questo è facile, cioè ti eviti tra l'altro la parte più costosa che è il soggiorno.
Sì,
No, perché Parigi, sai, cioè, è bello.
È gigantesca, è carissima.
È gigante, poi non è la stessa cosa stare dove siamo noi e dormire a Parigi, perché Vabbè, perché non siamo in centro, quindi c'è tipo se vuoi tornare, se vuoi uscire la sera, devi tornare o con l'ultimo treno, che comunque è dopo mezzanotte o mezzanotte e mezza, quindi va bene. O, però se vuoi fare proprio seratona, o ti si prende un Uber, oppure uno si deve pagare l'albergo a Parigi, che però costa una fucilata.
Madonna, addirittura.
Però non è un problema, cioè noi usciamo un po' prima di solito, così torniamo tranquilli col
Per
treno delle
mezzanotte.
11:30.
Ah,
Ma sì,
11 e
anche quello
mezza.
prima, che l'ultimo è tipo, sai com'è, l'ultimo treno di notte è sempre pieno, zeppo e gente, perché è
Sì,
come
nelle grandi
fosse in ora di
città.
punta.
Sì. No,
Invece,
guarda,
vabbè,
idem a
comunque,
Milano con l'ultima metro il sabato e il venerdì.
eh,
Cioè, l'ultima metro Milano è piena di ragazzini. No.
cioè diventa la discoteca / sala fumatori.
Grazie. È
E
vero, dai, no, vedi.
praticamente, se vuoi, cioè, nel senso, non è come stare a Parigi per questo motivo, ma per il resto sì, perché ad andare in centro ci vuole poco.
No, ma certo, io tutt'è che ora passo un attimo sto momento di sballonzolamento perché sto cambiando vita.
Adesso tu torni a Milano, no? Se mi ricordo
Sì,
bene.
sì, mi hanno fatto 2 anni di assegno di ricerca al CNR a Milano.
Stesso tipo di lavoro, cioè stesso progetto.
No, progetto diverso, lavoro diverso, ma stesso istituto.
Ah, beh, sei contento
Sì.
di cambiare?
Sì, no, è un po' strano, non al 100%, perché però ho valutato vari fattori ed era la cosa migliore da fare. Però, cioè, bello, nel senso, torno un po' lì, tra l'altro torno in zona dove ho fatto l'università triennale,
Ah, in
perché
Bicocca, sì.
l'edificio del CNR a Milano, a parte che ci sono varie zone, il CNR sta un po' dappertutto, però a Milano ce n'è uno che è in zona campus Bicocca. Quindi sei attaccato all'università, ancora più figo. Non è come qua, magari sono in un campus che è nel mezzo del nulla.
Certo.
Cioè, quindi stare vicino all'università comunque è carino. Il mio obiettivo è sperare in un ambiente un po' più dinamico che in futuro può essere che in questi 2 anni ci metti in contatto con i professori dell'università e può essere che parte qualcosa, vediamo. Cioè,
Esatto, no, hai ragione.
sì, no, come mansione al momento un po' più noiosa, cioè dove lavorerò solo al computer, devo tipo lavorare, devo analizzare varie direttive europee, vado a lavorare un attimo in ambito legislativo al momento, e sempre di protezione di ambiente marino e costiero.
Sì.
Però qui l'alternativa era solo 1 anno, lavorare tipo in un progetto che si appoggiava a Eni, cioè rimanendo qua a Trieste, quindi sbatti di lavorare ancora per Eni perché l'ho già fatto in passato, cioè non avevo voglia e dovevo ammazzarmi di laboratorio, non c'era possibilità di pubblicare, quindi ho detto boh, cambio. Peccato comunque
Poi voglio
perché
dire,
essendo
stare a
proprio
Milano sei un pochino più connesso col resto del mondo.
sì, a livello geografico, a livello di tutto, esatto, tipo voglio venire a trovare voi, sono molto più comodo, cioè
Sì,
venire
anche per
qui.
me venire a trovare e per dire che fa, cioè è esattamente uguale che viceversa. Prima venire a Trieste appunto si può fare una volta, poi dopo diventa, invece Milano
Sì,
prendi in volo e sei a Linate, via.
cioè sì, ma in generale anche io spostarmi da voi che voi avete più l'appoggio. Sì, no, comodo,
Poi
assolutamente.
quando, magari esatto, quando ci becchiamo a Genova è più facile per noi prendere il treno e venire su o viceversa, che ci vuole
Ma
cioè è come se
viceversa,
fossimo nella stessa città.
io Genova, sì appunto, Genova Milano niente, cioè ma io lì c'ho Fabri che se vado da lui, c'ho il mio amico di Via Torti che se vado da lui, quindi
È quello
cioè,
calabrese.
sì, esatto, quindi loro, cioè tra Fabri e il mio amico di Via Torti sono sempre disponibili a ospitarmi quando voglio, quindi Fabri me l'ha detto proprio pochi mesi fa, quindi figurati. E niente,
Perfetto.
a me lo scazzo di Milano è che no, se dovessi rimanere lì in qualche modo, perché non so se è una scelta definitiva, è il problema andare a vivere da solo.
Però
Cioè,
scusa, tu avevi una casa, cioè dove stai adesso paghi
no, adesso
quanto?
torno dai miei. No, cioè, quel bello di Trieste era che a Trieste ti pigli un appartamento con 400 euro.
Ma a Milano una camera in un
A
appartamento?
Milano sei fortunato se trovi una camera a 500-600 euro. sei fortunato. Una camera. No, appartamento, cioè Milano città, appartamento.
No, vabbè, Milano città lascia stare.
No,
Fai prima venire a Genova a fare il pendolare.
sì, esatto. No, non so dirti, ma veramente, ma per un monolocale inizia a diventare tipo sui 800, 900, anche 1000
E poi,
euro.
tra l'altro, solo a parte il costo del treno, però
Sì,
quando ci
infatti.
sarà il Frecciarossa in 40-50 minuti da Genova a Centrale, uno può fare davvero il pendolare Milano-Genova.
Sì, tipo mio fratello fa pendolare Milano-Torino. Cioè,
Lì c'è l'alta velocità, come ci va lui in macchina o in treno?
sì, no, col treno, dice che è ancora è più comodo col
Ci
treno.
credo. Bravo, va
Cioè,
bene.
non mette
Poi spenderà,
niente.
spero, meno col treno, perché la macchina, cazzo, sono ogni volta di fare Milano-Torino tutti i giorni.
Sì, spende pure meno, sì, indubbiamente. A parte glielo paga l'azienda, però,
Ah, beh,
però
allora,
sì.
con te
No, sì,
sei.
ormai il Frecciarosso, l'Italo fanno Milano-Torino in un'ora. Cioè,
Che
pensa
figo,
che
Milano-Torino in un'ora.
se veramente dovessero fare sta linea veloce Milano-Genova, non so in che modo, spaccando tutte le montagne.
Il tunnel è pronto, devono finire
Il
tutto il resto. Il problema è che l'alta velocità, paradossalmente, appena finiscono i lavori nel 2024, fine 2024, l'alta velocità sarà tutta in galleria, che è la parte più difficile. Quindi quella parte più difficile è fatta. Però poi quando sbuchi a Tortona, da Tortona a Milano ancora non c'è l'alta velocità, se ho ben capito.
Ah,
Che però è
ecco,
pianura,
sì,
cioè non ci
passa da
vuole niente, lì è
Pavia.
veramente,
Sì,
cioè, è
sì, lì è
facile.
pianura, vai, è facile, sì, no, ma da Tortona è tutto. Il problema è quando inizi ad arrivare a Roncoscrivia, quelle robe lì, il
No, quella
treno.
parte lì già la taglieranno ad alta velocità, sarà
Ah,
tutto, c'è il tunnel più lungo d'Europa.
quella miseria, porca
Sono
troia.
50
Non
chilometri.
andrà un cazzo di telefono quando sei su quel treno.
Però in teoria ci metti poco a fare 50 km se vai veramente ad alta velocità.
Se vai a cannone. Beh, io non pensavo che riuscissero mai. Chissà
Sì,
come
sì.
gestiscono le cose di pressione in galleria, te che sei esperto. Oh, aspetta, bossiamoci un attimo.
Adesso ci vedi che è una cerimonia.
Speriamo che no, chissà come. No, comunque ho intenzione di. Io mi trasferisco settimana prossima.
Già,
Quindi
no,
è la
mi
mia
ero
ultima
perso.
settimana. Sì, era l'ultima mia settimana a Trieste. Infatti
Ah,
faccio un evento al museo venerdì qui per la notte dei ricercatori. E sono anch'io col mio banchetto al museo. E niente, domenica dovrei sbaraccare tutta quella casa lì che hai visto. E mi dispiace perché mi ero affezionato, comunque avevo trovato il mio mondo in quella casa e niente, vabbè, pazienza. Vivrò
immagino.
fuori casa. Vivrò fuori casa come normalmente per lavoro ci succede. Cioè, quindi, boh, me ne
Posto
vado
che
in
non è
Brasile.
sconosciuto, dai.
Sì. E niente, quindi appena riesco, ora a ottobre col nuovo progetto devo lavorare un casino. Infatti la cosa un po' che sta nuova tutor, sta nuovo progetto, al momento vogliono che lavoro a ritmi un po' più alti rispetto a quello che mi era capitato qui. Però appena riesco, il primo weekend dovrei andare a trovare Ste a Sion. E cioè da
Ma a
Milano
proposito, te lo alzano lo stipendio con il discorso che hai già
no.
esperienza? Che
No,
infami.
purtroppo no, perché passi nella ricerca, almeno al CNR, funziona che tu inizi un assegno, può essere rinnovabile fino a 3 anni. In quei 3 anni può esserci lo scatto di pagamento se ci sono disponibili fondi. Tipo io qui a Trieste non mi potevano fare lo scatto perché i fondi non erano disponibili. Però tu, a parte che al CNR puoi fare massimo 12 anni di assegno, in totale, anche spezzettati negli anni, però ogni volta che ne finisci il ciclo di 3 devi ribandire, quindi devi partecipare a un nuovo bando pubblico. Cioè, quindi io tipo qui, se dovevo rimanere qua a Trieste anche per una questione di progetto, dovevo fare un nuovo bando pubblico adesso a novembre. Cioè, quindi l'ho fatto lo stesso, ma l'ho fatto qui. No, ma c'è stata proprio questa coincidenza che hanno aperto degli uffici del mio istituto marino a Milano, cioè, ma quest'anno. Si è saputo quest'anno. Quindi mi è un po' piovuto addosso. Sarà lavoro tutto di computer, un po', cioè, a livello come fai tu, cioè che stai sempre al PC, però bene, pazienza, così mi muovo. Cioè, il bello che quando lavori al PC, dopo che prendi il via, non so, mi muovo, anche se vuoi andare, non so, a Sion o a Genova, posso provare a portarmi il PC dietro.
Sì, ti faranno fare telelavoro, ne hai già parlato col capo.
Sì, il primo periodo preferisco andare lì perché stiamo cercando di capire bene come organizzare il lavoro.
No, però poi dico nel futuro, tipo se ti vuoi prendere una settimana di telelavoro da una parte, lo puoi fare.
Sì.
Tanta roba.
Sembra di sì. Sì,
Poi non ci
infatti.
torni più in laboratorio dopo che...
No, infatti non è come qua a piedi, ma... no, quindi su questo tanta roba. E poi vediamo. L'ho vista come opportunità di andare in zona università anch'io per la questione dottorato. E vediamo un po' come andrà. Detto, mi ero ambientato soprattutto quest'ultimo anno, quando è iniziato ad andare meglio qui a Trieste, stavo iniziando a conoscere un po' più di gente, però niente, ho detto no, vabbè, senza rimanere qua troppi anni, cioè perché hai capito poi troppi anni di affitto così, cioè tu dici, boh, non so, a questo punto facevo un investimento.
Giusto. Eccolo.
Arrivano?
Com'è?
Olè.
A posto.
Stiamo registrando tutti i cacchi nostri.
Poi me li vado a sentire.
Che in bolla.
Madonna.
Ma Ste, come funziona il voto di dottorato rispetto a quello di laurea, nella mia ignoranza?
Non esiste.
Come non esiste? Esiste un voto?
Non esiste, mi
I
dicono...
cartelli da 1 a 10.
Non esiste, mi cantano dottore, però...
Ti regalano due pomodori. Una sfogliatella.
Ma no, magari.
Ma magari, appunto. No, ma infatti
Vale,
che senso ha?
comunque come si chiamano? I fiocchi di neve, cioè il nuovo dolce preferito.
Bella,
Di
grande,
neve,
immagina.
No, come si chiamano?
Fiocchi in
Ah, i
No.
fiocchi.
Ah, vabbè, sì, no, ma li chiamano in tutti i modi. Poi se vai nelle altre pasticcerie, che non è quella originale, la chiamano poppelle, quindi...
Ma no, ma siamo andati, ma non erano buone, cioè da
Insomma, le fanno più
Poppella...
piccole. No, Poppella
Sì.
te la fa gigante
No.
e poi spinge, è quella storica.
Ma sì, ma poi è, come dici tu, Vale, una morbidezza mai vista.
No, il nome è azzeccatissimo, che ti schiaffi un agglomerato gassoso in bocca. In tutto ciò abbiamo una terza persona che magari sta ascoltando tutto. No, grande, fa piacere, c'è stata, ha fatto bene a schiantarti di cibo buono prima di questa discussione di dottorato.
Sì, sì.
Mi ha fatto piacere.
E Tullio, tu quando vieni a Genova?
Appunto.
Venerdì, prendo il solito aereo, arrivo alle 2:30.
Dai,
E poi vado via lunedì, come al solito.
Dai, bella, poi fai sapere che ci becchiamo anche lunedì, magari.
Voi sarete a Genova? Sì.
Sì.
Okay.
Quanto ci rimani?
Sì, allora...
Fino a lunedì anch'io.
Ah, ok. Ci sta. Alla prima possibile ti aggiorno e vengo a Sion.
Va bene, vai, ti aspetto.
Sì. Mo tutta la settimana prossima mi stabilizzo un attimo, poi niente, no, perché c'è la nuova tutor che mi sta prendendo col crick,
Sì.
quindi sì, c'è una scadenza il 27 ottobre.
Quanto? Dai, allora.
No, però appena...
Aspetta, vi
Giulia.
metto... Aspetta, che non vi sente vicino, che c'ho le cose.
Ciao Giulia.
Eccola.
Auguri.
Grazie.
Ho sentito un po'. Ciao
Ha
Angela.
sentito i primi 10 secondi.
Ciao,
Grazie, sono sufficienti.
bravo. Allora hai avuto il risultato?
No, adesso stiamo aspettando, infatti tra poco si ricollega la giuria e poi
Noi andiamo a
dicono...
mangiare, che dobbiamo andare a una visita medica subito dopo.
Vai. Poi ti vedi la registrazione su YouTube.
Sì, vedo ogni singolo... E ci vediamo venerdì, ok? Giulia purtroppo non può venire perché c'ha una visita medica di nuovo lunedì e sono visite mediche che non possiamo rimandare, se no ce le rimandano a fanculo.
No, perché mi voleva lasciare qua. Voleva andare da solo e per quello.
Ho capito.
Scoperto.
Ho capito. Va bene, grazie comunque.
Dai, ci becchiamo, ok?
Ci vediamo.
Salutatemi i
Ciao,
prof.
Sì, ti salutiamo proprio.
Ciao ragazzi, ci vediamo presto. Ci vediamo presto.
Buon tutto.
Grazie Tullio.
Ciao.
Adesso vediamo solo Vale.
Sta facendo finta di...
Com'è lì a Milano?
No, non sono ancora lì, qui, aspetta.
Ah, sei a Trieste?
Sì, sono a Trieste, stavo salutando i colleghi, che qua a mezzogiorno in punto si mangia, aspetta. Perché io condivido l'ufficio con un collega, ora sono andato in un'area comune, area macchinette, perché condivido l'ufficio con un mio collega, però ora lui se n'è andato a mangiare, torno nel mio ufficio.
Ci sta.
E sì, sono gli ultimi giorni. Domani è l'ultimo giorno che vengo fisicamente in sede. Domani. Perché venerdì devo passare tutta una giornata al museo, come ti ho già detto per la terza volta. E niente, poi mio padre è salito ieri da Pizzo, ora sta a Milano. E tra sabato sera e domenica dovrebbe venire mio padre qua a Trieste e niente, smonto la casa.
Capito. E come stai?
Un po' combattuto, è comunque un cambio di vita dopo 2 anni, cioè, quindi però niente. Conto, sì, quindi il cambiamento all'inizio è un po' traumatico, ma poi conto che poi appena mi ristabilizzo andrà in bolla. No, vabbè, mi pia bene andare comunque lì in zona università, quindi di nuovo un po' più dinamica al campus lì della Bicocca. E niente, quindi sì, settimana prossima sono già lì al CNR di Milano. Perché vado, sì, anche se è tutto un lavoro in computer, conviene andare in presenza, ma mi piglia pure a me meglio, cioè io sono il tipo che se sta a casa col computer a lavorare cazzeggia troppo, quindi cioè anche qui tipo in sti giorni già non sono più burocraticamente non sono più sotto contratto alla sede di Trieste, sono già con la sede di là. Però sto venendo lo stesso qua, perché c'è un mio collega che... Aspetta che mi sa che qualcuno si sta connettendo. Vediamo sta proclamation. Questa è la mia postazione con 100 schermi.
Bella. Sì, vediamo
password
la password. Ok, ce l'ho.
Devo appoggiare. No, e comunque, vabbè, peccato mi perderò la festa, ma facciamo una festa privata.
Questo è il mio amico, caro amico della Calabria, di Napoli, di Milano.
Ah, ok.
Lui è il famoso Fabrizio, vabbè, ora tra poco
è
smetteremo
vero,
questa conversazione.
Comunque non è andata bene.
Non è andata bene. Vabbè, allora...
Hanno detto che c'è solo un modo per migliorare,
Cioè?
Devi corrompere, per prendere più decisioni devi corrompere.
Fabrizio Solz.
No!
Questo è il regalo più cazzato.
Grazie.
C'era un biglietto che ho perso perché se non mi hanno due tre frenate grosse in macchina e tutto è partito.
No.
Il mio regalo è il regalo
C'è
più
il
cazzato.
cibo.
No.
No, questa è l'altra droga, è legale.
C'è la bomba, c'è la novità.
Questa rossa?
No, quella rossa la conosci già.
Ah, ok, scusa, quella rossa.
E questa è per la novità
Fabio,
addirittura
cos'è?
del
Cos'è sta roba? Dove l'hai presa?
Le torta, le noci, le grigioni, questa è
Ma
bomba.
cosa dici?
È bomba.
Vabbè, allora poi l'assaggiamo.
C'è un
Cos'è
biglietto
burro?
che l'ho perso. Ah, questa
Novità.
è la novità. Novità.
Vabbè,
Che l'hai scritto tu.
ti ringrazio.
C'è un biglietto che l'ho perso.
Vabbè, lo ritroverai, poi me lo ritroverai.
Non
Grazie.
sapevo, cioè quando mi è venuta
Grazie.
l'idea era troppo stupida per me.
Vabbè, grazie. Lo sai che per me questo è il massimo che posso ricevere. Ti
Questi
ringrazio.
qua, madonna.
You have to want to ask. I have.
Can we, if you send me the PDF, I can sign it in 2 minutes online. It's actually quicker for me. I can just
It has to be signed
by hand, but I mean the one that because then in any case you have to do a PDF for jobs.
He will, because we send the originals, has to be seen at the person's house. I will print it.
My signature is handwritten. It's not
It's not accepted.
Yeah, but then in any case, yeah. But then you ship it, you send it back by post. You send it back by post.
Thank you very much.
The school will see it's possible.
It's done.
Anymore.
We can ruin everything
Not
about
by email, but by
I have to send it to him by post.
Questi li nascondo perché sennò mi sa che mentre li programmano si partono subito. Questi si ti beccano perché...
Maybe okay. Yeah, I would ask maybe the members of the jury to activate the camera.
Okay.
And the others who are connected, maybe not. Just to have a picture with the jury after. So let's wait a couple of minutes. We have the other members.
Okay.
Have a picture with
How do we take a picture like here?
You can display your PhD. Couple of minutes. Elena, who is missing? Sadiq. Is Sadiq connected? Or? Okay, Sadiq is connected.
Grazie. Bonjour. Trino réunion, vas-y, vas-y. استاذ عمري لا تحطنا خلينا فيديو كونفérence. خلينا فيديو كونفérence. Voilà. Après بروحها. Après je parle. Voilà. Mais à chaque numéro, la semaine prochaine avec plaisir.
Okay, so we can proceed to the last part. I would invite the jury to have the camera open, which is the case, and maybe the other people connected to put in mute. So I pass the floor to the president of the jury, Joao.
Okay. So so I'm now going to give you the decision of the jury after the deliberation. I'm going to read what we wrote about your thesis, Stefano. Okay, so Mr. Stefano CASSANO defended his thesis entitled Control and Scheduling of Hybrid Hydropower Plants with Batteries for Enhanced Flexibility in Future Power Systems. He made a clear and synthetic presentation of his work. The presentation was of good quality and easy to follow and showed his pedagogical skill when describing a non-trivial high-quality research work as presented in the thesis. The subject was very complex and involved several questions from the jury. The candidate was capable to justify the assumptions made in the thesis and managed to provide very comprehensive and fair answers that went even beyond the scope of the thesis. He was able to elaborate and put forward his contributions to the field and prove to have a good knowledge of the problem. In conclusion, the jury agrees that the work brings original contributions, is well presented, and of value to both scientific community and to the relevant industry, showing he was capable to master the scientific method. Therefore, the jury unanimously decided to award Mr. Stefano CASSANO the grade of Doctor in Energy and Process of Paris Science and Letters University. So, Stefano, congratulations on behalf of the jury and myself, and I wish you all the best in your new life that starts from today on. Congratulations.
Thank you. Thank you. Congratulations.
So I would like to spend some words, if I can.
Okay.
Okay. So I would like to thank all the people that helped me during this journey. There are so many, so I'm super happy of that. First, I would like to thank the jury, so Professor Lopez, Professor Baccia, Professor Young, Professor Pallone, and Professor Vagnoni. Thank you very much for the time you spent reading my thesis, for your feedback, and for this very interesting discussion you brought today here. I really appreciate it, and was like very interesting to speak with such an expert in this field. Then I would also to thank the partners of X-Plex Project Hydro, because it was my first project, and I had the chance to work with so many experts so I learned a lot, and it was really nice. Then I would like to thank my supervisor, George Fabrizio. Thank you for everything you taught me, many things, and for the advices, but mostly for the time we spent together. And especially thank you, Fabrizio, for being such a great mentor and friends, and for working with you was really inspiring because of the passion you put in your work. And I think this is the best gift that you can do for other people. Then I would like to thank my colleagues that are here. Thank you very much. I would like to start with our office, because of course. So thank you, Valentin, Kevin, Ongjin, and Fion. Then I would like to extend thanks to the other offices, of course. But there are too many names. Perhaps I would say the names that are not here today. So thank you very much for this journey, because it would have been the same without you, for sure. And also I thank, I don't know, like Achilles is not here, Shengfei, I don't know where he's supposed to be here. And then who's missing? Owen, it's difficult because to check, okay, and Bisharup that is connected. And then I want also to like some external people like Raul and Francesco, because they helped me also. And then, of course, I thank my family that is not here today, but it's okay, my sister, and all my friends from Genoa, so my big family. Some were connected before. We have a talk that if you are interested in, you can see on the YouTube channel of the school. And then I would like to thank Marise, the lady was there before. She hosted me in this amazing chalet, and we spent so many beautiful moments together. And last, my girlfriend, thank you very much for your support, especially in the last moments, like since 1 second ago. Thank you for also sopportarmi in Italian, I won't translate. And thank you for your love that you give me every day. And thank you very much. So, unfortunately, for the people who are not there, now we are going to having a little buffet with typical products of my region, which is basically a lot of focaccia and other stuff. So I hope to meet you perhaps in the future in person. Okay, so
but without focaccia.
Without focaccia, or we don't know.
You know, our world is small, so for sure we will meet somewhere in conferences or so. Okay.
Yeah.
All the best. Congratulations. Bye-bye.
Thank you.
Bye, everybody.
Bye. Thank you. Bye.
Thank you, Stefano. Congratulations again. Bye.
Thank you very much.
Congratulations.
Congrats,
Thank you, everybody. Bye. Thank you. Bye-bye.
Bravo, complimenti, un bel discorso, capito? Perché non avevi tempo per...
Hai visto? Perché ho fatto